In this video, I'm going to have a go at turning this engine over, and before I can do that, I need to tidy up all the wiring on the ballast, resistors and the coil. We need to test the starter motor, sort out and fix any wiring on the neutral safety switch which isn't working, and then we should be just about at the point where we can turn the key and see if the engine turns over. We're going to have a go at sorting out this wiring here, and the first thing we need to do is cut this non-OEM bit of wire here and then strip a bit of wire. Next I'm just going to slide on a little bit of heat shrink. Then we're going to use one of these little fittings here. It's a really tight fit in there. We're going to crush that down. Then we are going to hopefully be able to slide this heat shrink over there. All we have to do now is just heat that up, and that should seal that perfectly. Next up, we're just going to add a little hoop onto this green wire here. We'll just snip the end off the old wire. We'll just slide a little bit of heat shrink over there. Slide this fitting on there like so, and crush that down. Now the last thing we have to do is cut this yellow fitting here off, because the hoop is too big to fit into that fitting there. It needs to be a smaller style of hoop. It's interesting, on the gold car there's actually two wires coming out of the green wire. There's an earth wire coming out of there as well, but on this car there's just a single wire. So I don't know if that's got something to do with the fact that one's a 450 and one's a 280. We'll put some shrink wrap on here. We use slightly thicker shrink wrap this time because the wire's slightly thicker. And we should just be able to thread that through there, like so, and crush that down. So we should now be in a position where we can connect all of this together. We finished wiring up the ballast resistors and ignition coil. The ignition coil and bracket have been painted, and I'm just very quickly going to run through how this should be wired up for a D-Jectronic car. So the ignition coil has an earth wire coming from the negative terminal, or terminal number 1, and that is earthed to this bolt here on the chassis of the car, and that leads to this connecting block here. The upper pin of the connecting block, or joint of the connecting block, is the earth to this block and leading to the negative terminal of the coil. The positive terminal of the coil is wired to this side here of the top ballast resistor. That's the 0.6 ohm ballast resistor, or the silver ballast resistor. The other side of that ballast resistor, which is a black wire, is the black wire coming out the ignition control module, which lives on this car in the front footwell underneath the car. This ignition control module wire has 4 wires coming out of it. The black one goes here. The red one goes to this side of the blue ballast resistor. The green wire goes to the lower terminal of the connecting block, and the brown wire goes to the upper terminal of the connecting block. So you've got green, brown, red, and black. Now this little unit here, which you've probably never noticed in your life, is a terminal, a D-Jectronic testing terminal, which if you have special D-Jectronic testing equipment, you can set the dwell angle and all sorts of stuff like that. That has 2 wires coming out of it, a green wire which attaches to the green here, and a black wire which attaches to this side of the ballast resistor here. Now the other wire that attaches to that side of the ballast resistor is the wire coming from the firewall. It should, I believe, be a black and red wire. They've joined it here, so the colours have changed slightly. So there should be 3 cables coming from the firewall of the car. The black and red to this side of the ballast resistor, the red to this side of the ballast resistor, and the green and black joining up to the green and black terminal down there. Now, with the ignition switched on, i.e. the red ignition light on the dash but the engine not running, these 2 ballast resistors are going to get very hot. So when you wire this car, make sure you do not have wires leaning on the ballast resistor. This socket here is for a Mercedes cable tie that will slot into there, and that should be held there, and this wire should actually come around the back of the ignition coil, so we'll change that. But it is quite usual for these 2 to get hot. One of the last things we've got to do is put this Mercedes cable tie in. Now these click into the hole, and then that hole is spread by this plastic pin here so that the thing can't come out. I'm going to tap that in. Then that can just go through there like so. We'll snip that off. That'll ensure that that doesn't touch that ballast resistor. We've got the red ignition light on. Got the negative terminal of the voltmeter on the earth. You can see the 7.6 volts at this side of the resistor. On this side of the resistor, that drops down to 3 volts. On the blue resistor, you've got 8.1 volts here. Oops, and that's 11.5 volts there. These resistors are hot to touch. You could not hold your hand on there. They are hot. We finished tidying up the wiring over by the ignition coil, and before we get involved in starting the car, the first thing I've done is just changed all of these screws here for non-rusty ones, and gone over each one of these fittings here with a little wire wheel to clean them up, because the last thing you want to do is start testing stuff with dirty connections, rusty connections, because that might throw all your readings and give you an unexpected problem. So this has 12 volts to it, this has 12 volts to it, these 2 have nothing. These 2 only become live with 12 volts when you turn the ignition to crank. Now, this car used to be a manual, but is now an automatic. So let's put an automatic box in here, and an automatic gearbox has something called a neutral safety switch, which means that these starter motor terminals here will only get power when the car is in neutral or park. Now I'm going to have a go at cranking the car, but before I do so, I just want to demonstrate something. So I've got the negative terminal of the voltmeter set on the negative terminal of the battery. I've set the voltmeter to resistance so that when it beeps, we know that there's continuity. And if we touch this on these end 2 fittings here, you can see that at the moment, these 2 terminals are both earthed. Okay, I've now set the voltmeter to volts, and I've got this touching the purple terminal, the end terminal, and I'm going to crank the engine. We've got the red ignition light on and cranking. So there is no voltage to this terminal here when we crank the engine, and I think that is because the neutral safety switch is not working or is not connected up correctly. What should happen when you crank the engine, you should get 12 volts to this wire here. That wire there then activates the solenoid on the back of the starter motor, completes the connection and turns the engine over. Just going to very quickly run over how the starter motor is wired. Now this is the starter motor here. Its body is connected to the earth, so it's bolted to the side of the car, the engine block of the car, and that's earthed like so. And there is a positive connection, permanent positive connection from the solenoid on the top, which is basically just a switch to the positive. And when you apply voltage to this terminal here, when you apply 12 volts to that terminal there, that closes the switch and allows this to work. Now when I turn this switch on and off here, that starter motor will engage briefly. And you can see the starter motor not only spins, but the shaft comes out. So we know that this starter motor is working fine. And we know that when we apply power to this terminal of the starter motor, the one nearest the big positive terminal, that's how the starter motor connect the plus to the bottom terminal of the starter motor. The same thing happens. You can see that the starter motor spins and works. So when we energize this terminal here, this terminal is energized with 12 volts, and one of these terminals will go off to the ballast resistors to give the ballast resistor 12 volts directly from the battery. But that'll only be energized when this wire is energized, and this wire will only be energized when the key is cranked and the car is in neutral or park. Okay, now the moment of truth. If I take this positive terminal here and touch it on the positive there, nothing should happen until I press that switch. Okay, so far so good. Now when I switch this switch here on, that will simulate the key in the ignition and should, in theory, turn the engine. This engine hasn't been turned for however many years, so I've got no idea what's going to happen here. I might get electrocuted, there might be a huge spark, I might blow some fuses, I've no idea. But what I've done is I've hooked the positive terminal of the battery directly to that thick purple wire. Okay, here goes nothing. That engine will either try and turn or something will explode. Okay, well that was definitely the sound of the starter motor. Let's just try that one more time. Okay. So we've made a major move forward in this car. We've ascertained that the starter motor works and that it turns the engine, which is great. We've also ascertained that when we crank the car, turn the car to crank, that thick purple wire is not getting any power, and I suspect that's got something to do with the wiring on the neutral safety switch, which is on the automatic gearbox. So we're going to have to jack the car up and have a look at that wiring. The other thing I'm not seeing or hearing is that when we first turn the key to the on position without the car running, that fuel pump should run for 3 seconds, and I'm not hearing that fuel pump running. Now there's no fuel in this car yet, so the other thing we have to do is put some fuel in and actually test that all the fuel fittings that we've hooked up are leak free. Now the other thing we're going to do is make sure that we're dealing with a fully charged battery. You can see that this battery here is reading 12.4, which means it's about 30 to 40% discharged. At 12.2, that's 50% discharged, that battery. So that battery should be reading 12.7 or above. The other thing to bear in mind is on a Dejectronic car with a transistorized ignition module, you must not put a rapid charger across these terminals. You need to disconnect the battery from the charging circuit first, otherwise you will fry that ignition control module, and that is an expensive thing to replace. I think I have sorted out the wiring to the neutral safety switch, and if I'm right, when I turn this key here to ignition and then one click further, the car should attempt to start. And there you go. Just to test that I got the other wiring right, we'll put the car in reverse, which is just one click this way, and when I turn the key to ignition here, the reverse lights should come on. And look at that, they do. Wow, what a major breakthrough. I think I'm going to finish this video here and go to the pub to celebrate and have a pint. We've sorted out all the neutral safety switch wiring underneath the car. It works. We've tidied up all of this wiring here, pinned it to the car properly, got the correct ballast resistors, got the correct coil, painted the coil, changed all the screws there, cleaned all the terminals up, In the next video, I'm going to put some fuel in this car and see whether the new fuel tank we put in and the connections, etc. leak. We're going to try turning the key and seeing what happens if the car fires up. We have still got a ton of work to do. We've got to sort the brakes out. We've got to sort the radiator hoses out. We've got to sort all the vacuum system out. But we're really making headway on this car, and as I say, my ambition is to get this car running by the summer, and who knows, maybe even driving.